Yeah.
Yes.
Okay. Hello, people. So, so this was like initially supposed to be a PSS, but due to something, we will be doing config geo today.
Sorry,
So,
but could you talk a bit louder? I've put it at full volume and I'm not able to.
yeah. Okay. I'll just increase my mic setting. Just a second. How about now?
That's fine. It's better.
Yeah. Thanks. So, we'll be doing config geo today, and at the end, I intend to solve a couple of problems based on like involving config geo ideas as well as inversion and projective. So, wait, why am I using this thing? Okay, so what is config geo? So config geo are a bunch of configurations which will like repeat many times in geometry questions. So it's good to it's good that you know a certain set of points and their properties so that so that you can like directly apply in the problems. They won't ask you to prove properties obviously, but uh, the points may appear in various problems by various definitions. So we will be starting. Okay, so I'll try to draw good diagrams as far as possible, but if not, just pardon me. Okay, so we'll start with the Dumpty point. Also, these points are so the whichever points we will discuss today are not symmetric with respect to all the three vertices. They are defined by with respect to a single vertex of a triangle. Like you have the A Dumpty point, and then similarly you have B and C Dumpty points, and these are like distinct. So we will mainly study acentric because we like acentric triangles. Okay, so how do you define this thing? So this is a triangle. Uh, second. So what we'll be doing, the course will be like, we will do some properties of this and we will try to prove it. So there will be a bunch of properties for each point and they are like logically arranged in a sequence. So you should be, so there should be no jump in the properties. Like you should be able to derive from whatever you have done before. Okay, so you have this, then you construct the median of A and the circumcenter. And so this point. So this K is the K dumpty point of triangle ABC. Okay, so this is the definition of K that you take the AC median and draw perpendicular from the circumcenter. So we just name these points S and T. So based on this, so this is a point on the C median, as you can obviously see. So many times when problems ask you like to show some so that this circle passes through a fixed point on the median or something. Many times you can observe that it's probably the dumpty point. It's not hard and fast, of course, but you can sort of guess and try a few cases to verify. Okay, so we'll start with the properties of dumpty point. So first is like obviously since this is perpendicular, you have AK equal to KS. Second is like BOKC is cyclic. Okay, like can anyone quickly outline the proof of this? I'll give you a couple of minutes to. Yeah.
Okay, so angle BKC and angle BOC can be compared.
Angle BKC and angle BOC. Okay, that's interesting. So you know angle BOC is 2A, right? Is there any way you can calculate angle BKC?
Wait, I think BKCT is cyclic.
Yes, yes, that's true. That's true. So can you just formalize?
1 second.
I think B, K, O, C, and T, all of them forms a circle.
Yes, yes, that's true. Could you like outline the proof quickly?
Mm, we take the diameter OT, which is obviously the diameter of OBTC because they are the tangents, so they are the
Yes,
perpendicular.
yes, that's true. So this is the circle with diameter 40. And what is this? This is the
And
circle with,
K is also perpendicular.
yes. So this is the circle with diameter 40. That's nice. So we know that BOKC is cyclic. Like I should probably keep this diagram. Also, like if you're able, like just if you have access to pen and pencil, just keep the diagram handy with you. That you know, if I scroll down and you miss the diagram, it will be easy for you to refer. I'll try to keep the diagram on screen as far as possible, but just in case. Okay, so next property of this point is you have AMK and is cyclic. Oh, sorry, I need to find these. So M is the midpoint of PA and N is the midpoint of AC. So you have that AMKN is cyclic. Can anyone try to give a proof for this?
Again, we can use the same idea on AOMNK. So
AOM. Yes. So this is diameter.
diameter is AO and 90 degrees at K.
Yes. Next. True. So also like one more way you can identify this is homotherity centered at A with ratio half. So B goes to M, S goes to K, C goes to N. So that's the circle. But like this is nice. This is nice. This is no worries about this. Okay. So is everyone with me till now, or are there any doubts? Also, like, feel free to interrupt me whenever you want to ask
What was
something or
the
point out
homotopy?
something.
What was the homotopy?
It is, so this is the first proof, and the second proof is homotherity centered at A with ratio half. So that takes B to M, C to N, and it also takes, and it takes S to K by, by this argument.
Oh, okay.
Yes. Okay, so you didn't miss quite a lot, so we just started. So we are doing config geo today. So this is the first duality point configuration. So duality point is defined as the perpendicular from circumcenter to the symmedian, and these are the first few properties I've outlined: A, B, C. So the proofs are like outlined here. You can check and ask if there are any questions. Okay, so let's do the fourth property. Okay, so this is quite an interesting one. This appears many times during angle chasing and etc. So what you have is if you join, let's just scroll down and draw a different figure. That would be better. you have this A, B, C, and K. So you need to show that angle KAB equal to angle KCA and angle KAB equal to KC equal to angle KAC. So of course these are symmetric, so proving any one of them would suffice. Oh, yes, sorry. That's KAB equal to KC.
I think I've got the proof.
Sorry, I did not get you.
I think I've got the proof.
Yeah,
Like BC is a median for ABT.
BC is a median of ABT.
Yeah.
Right, why?
Sorry, for the intersection of that AT with the circumcircle, that point, ABX.
Yes.
Yeah.
Yeah. Yes, right.
And then we observe that since PK is a median for BAS,
Yes.
that means that it is just a reflection about the angle bisector of ABS. And thus SBC is equal to ABK.
Yes, that's true. I just like write down what he said. So you have that. Okay, so I'll be using the projective notation here. If I think you are, is everyone comfortable with that? Okay, I just ask, is anyone not comfortable with that? Okay, cool. So I think I'll like just use this. If anyone has any questions, just ask. So you have it's equal to -1. So in triangle ABS, BC is median and BK is median. So angle ABK equal to angle SBC equal to angle SAC. What did I write? Yes, that's true. Nice. So you got these two pair of angles. You got these two pair of angles equal. Similarly, these are also equal. Okay, so this is I mean this property comes up a lot of times. So it's another way you can define the Dumpty point. So in many of the questions, you will observe that this definition comes up. Okay, so an obvious corollary to this is that if you draw these circles, um,
Wait, so ASBC is a harmonic quadrilateral?
yes, because tangents at B and C intersect on the line AS,
Okay.
right? Is that okay? Okay, so if you construct these circles, you get that AKB is tangent to CA. I mean, I should write CA tangent to AKB, but same thing. And AB tangent to AKC. Does everyone follow why this is true?
But how you get that AS and BC is a harmonic bundle?
Sorry, could you come again?
How uh, you have find that AS and BC is a harmonic bundle?
Okay, so because uh, that in a cyclic quadrilateral, so tangents at B and C intersect on T, right? And T lies on the line AS. So you have that AC and ABSC is a cyclic is a harmonic quadrilateral. So you know that if you have a circle and you have two tangents and you have any line through this point, then this X, Y, W, Z. So X, Y, W, Z is harmonic. I- Is this fine or should I elaborate?
Yeah, got it.
Yeah, thanks. So is this is this obvious from this or
Yeah.
yeah, next. Okay, so next one is I'll just draw another diagram again. It's better to draw. So you have that BDMK is cyclic and tangent to MN, and similarly C uh, CDKN is cyclic and simple. So this is probably angle chasing unless anyone gets another proof. So I'll give you some time to try. Anyone has any ideas can just speak out.
MN
MN
at the midpoints.
yes, yes. I forgot to mention.
Okay, so I think I'm done.
Yep.
So if we prove it for BDMK, we are done by symmetry for CDKN.
Yes.
So we can first draw the center of the circumcircle O. We construct the
Okay.
point.
I just call it O dash. If is that okay? Because like O is like central ABC.
I mean, at center of circumcircle ABC only.
Okay. Okay. I thought you were saying okay. O will be like here.
And we have
Yes.
that KAC is equal to KBA.
K is equal to KB.
So if we call that theta or some number, I mean variable, then we have angle KAO is equal to theta plus B minus 90 degree. I mean, 1 second. Angle OAM is equal to theta plus B minus 90 degrees. Because angle OAC is 90 minus B and angle KAN is theta.
Yes, you're talking about angle OAKAO, right?
No, OAN, sorry. OAN.
OAN.
N.
Yes, so OAN is 90 minus B.
90 minus B. And then we get angle OA angle KAN is equal to theta plus B minus 90.
KAO, right?
KAO, yes.
Yeah. Yes.
Yeah, so then we have AMKON is cyclic.
Hmm.
So angle KNO is equal to angle KAO.
Theta plus B minus. Okay.
And then we have angle OMA is equal to 90 degrees. So angle OMB is also 90 degrees.
Yes.
So angle KMB just becomes 180 minus theta minus B.
Yes, nice. So this is KMO and OMA equal to 90. I mean OMB equal to 90. So that's in place KMB equal to what is it? 180 minus theta plus B, right?
Minus B.
Yeah,
Yeah. So then angle MKB is equal to B. But angle MDB is also B since M is the center of the circumcircle of ABD.
true. So MKB equal to B equal to MD.
So
That's
we're done.
good. Yes, nice.
I have another proof.
Yeah,
So angle CBS equals to angle NMK because of the homothety from A,
yes,
and because AMKN is cyclic, so angle NAK equals to angle NMK, which is equal to
yes,
theta. So we're done.
yes. Yeah, nice. Okay, so these are some nice proofs. So you get that this thing is cyclic. Also, that tangent to MN is like trivial because MB equal to MD. So the circumcenter lies on this perpendicular and MN parallel to BD. So you get its tangent. So it's like this or something. It will have to be this. Nice. So did everyone get these proofs?
Can you
Yeah.
explain the part after angle KNO?
This part?
Yeah, after that.
Yeah. So you got an angle K. I'll just erase those circles. Yeah. So angle KNO is equal to theta plus B minus 90. So angle KMO is also theta plus B minus 90. This angle. And OMB is 90. So you subtract that and you get angle KMB is this thing 180 minus theta plus B. So you get that angle MKB is B by angle sum property. And you know that in the triangle ABD, M is the midpoint, so MB equal to MD. So this angle is B. So you're done.
Okay, got it.
Nice. Cool. Okay.
1 second, in the
So
homothety proof, like what do we do after we get angle NAK is equal to angle NMK?
yeah, okay. So wait, just a minute. Yeah. So you get angle NMK equal to angle NAK, and angle NAK is nothing but NAK is KBA, right?
Yeah, it's KBA. Okay.
So sorry.
So yeah, you just continue 1 second.
Yeah. So now what you can do is you compute this angle BKM in like two different ways. So angle BKM is equal to angle KBS because this is the midpoint thing, homothety. So that is CBS plus CBK. Now just put this K. So CBS is KBA. So this plus this equal to angle B. So that's it.
Okay, got it. Yeah. So
Yeah.
you just did angle chasing after that.
Yeah. I mean, you got angle MKB is angle B, and you know that MDB is B by this thing 90 degrees.
Okay. Yeah.
Yeah. So this is some nice thing. Okay, so this was about the dumpy point. Okay, one more thing. So you guys have done inversion, right? I guess. Just confirm yes or no.
Yes, we have done it.
Yeah. So where do you think the dumpy point goes under the root BC inversion?
In root PC inversion or?
Yeah, root BC inversion under root BC followed by reflection about angle bisector. Where does the dumpy point go? I mean, what does dumpy point swap with? That's the question. So these things are quite useful because many times in config geo you will encounter inversion projective. These are like many of the config geos are go hand in hand with inversion. I mean, many of the inversions I have solved were config geos. So these are some quite nice properties to know. I'll just draw the diagram.
It
of
just
it.
goes to wherever it lies on the line MN. So I'm wondering where MN goes.
Yes, true. Yes, so where do you think M and N go under root BC? So let me just draw this diagram. This is like tangent. Okay? It's not local but just assume it's tangent. Yeah, so one locus, as you said, since AMKN is cyclic, it will go, so K dash will belong to M dash N dash. So where do you think M and N go? It should be C. Just use the definition of inversion.
Twice the length of AC? I don't know. Is there an error?
Sorry?
Twice the length of AC. So like M
Yes.
goes to twice length of
Yes.
AC.
So
So when it
I'll just draw.
reverses, it goes to the
So
reflection
I'll
of
just
A.
draw this in this figure. Yeah, go on.
So wait,
Go on,
M.
continue.
So wait, we get like it's B by 2 into X is equal to BC, where X is the distance between A M dash. So now we get X equal to 2C, which means that M dash. So M dash is a reflection of A across C.
Yes, true.
So it just lies on that line as.
Yeah, this is like parallel to BC. I mean, my drawing skills are like quite bad, so direct between. Why does it not erasing? Oh, okay. Yeah, okay, nice. So this is like parallel to BC. And what is the other locus?
Won't
So
it just be like the midpoint of M dash and dash?
yes, that's
Yeah.
true. Because yeah, so you know that AK is the symedian.
Also, it's
So
reflection across the
yeah,
angle.
AK dash will be the median. So that's just the median. And wherever it intersects MN, that will be the midpoint. So this is the reflection of A about the midpoint of BC. Right, so that's the parallelogram. A, B, K dash C. Okay, so let's move on. Was this inversion thing clear to everyone?
Yeah.
Nice. So let's just move on to second point that we'll be looking at. So second one is the Humpty point. So again, this is like we're really looking at a Humpty point. Also, these notations, I mean, these names are like quite slang, so don't use them in context. In context, you have to prove prove the properties that we have proved right now to in general show things. So that's it. So we'll be calling this as say HA. You will find out the reason soon. So what we define it is the perpendicular from orthocenter to A median. This is the A Humpty point. Should probably not the circle. We have this median. We'll extend this for some reason. And you have the orthocenter here. So this is the A Humpty point, HA. Okay, so first property we have is, I should name the points. And now the point which we see above, reflection of A about the midpoint M. Let me call it X. So the first property that we want is that A, B, H, HA, C, and X. These are
M is
concept.
the midpoint?
M is the midpoint of BCS.
Oh,
That's the definition of Humpty. It's the perpendicular from orthocenter to the median.
so what's the first property?
So B, H, HA, C, and X. These are concyclic. X is the reflection of A about M.
So just homothety again, I guess.
What it about what?
Homothety about A. Wait, 1 second. Let me just like think about it.
Yeah.
Natively, the circle with diameter hx.
Yes, that's true. So you consider a circle with diameter hx. So now you have that since ABX is parallelogram, XB is parallel to AC, which is perpendicular to BH. So HBX is 90 degrees. Similarly, HCX is also 90. So this is the circle with diameter hx. Is that clear?
Wait, why is ABXC a parallelogram?
You're reflecting A about the midpoint of BC, right? So you have BM equal to MC and AM equal to MX.
Oh, I didn't see that.
Yeah. So okay, so it's a trivial property. I mean, there's no need to write it. That HA is concyclic with these points, and this is a circle. Like it's just diameter HA. That's just easy to see. Okay, so let's move ahead. Maybe if we can do one more property in this diagram. So we have the second property, ABHA and ACHA are tangent to BC.
1 second. How do you prove the first property again?
So you consider the circle with diameter hx. So clearly HA belongs to that circle because that's by definition. Then ABX is a parallelogram because you're reflecting A about the midpoint of BC.
Okay, so AC is parallel to BX. Okay, so yeah,
Yeah.
angle AB is equal to angle B. Oh, got it. Thank you.
So second property is that circle ABHA and ACHA are tangent to BC.
This also follows.
Sorry.
Should I tell the group?
I can't hear you clearly.
Wait, let me check something. Wait. Is it clear now?
Yes.
So HABC is equal to HAXC, which is just equal to XAB.
True. Yes. So you get that these two are tangent. Did everyone follow this angle chase? Hello. Guys, like just reply with yes or no or repeat.
Yeah.
Yeah.
Nice. Okay, so we have this thing. Also, a corollary to follow directly by power of point is that MHA into MA equal to MB square equal to MC square. Does everyone see why? It's directly by power of point. MB is tangent to AHAB.
Yeah.
Yeah. So also one more thing we can deduce from this is that reflection of HA in M belongs to circle ABC. Basically, if we find this point, then these two lengths are equal. Can you see?
Yeah.
Yes. So does anyone want me to elaborate the proof or?
Yeah.
Can you repeat that?
Yeah. So if the median intersection circumcircle, let's name is like Y, then HAM equal to MY. So HAM equal to MY.
Okay.
Yeah, so should I go to the next property, or that proof is like just power of point again, MB into MC is MY
Yeah,
into
yeah,
MA, and
okay.
just
So,
bash this thing.
Sorry, I actually didn't understand that how do you get like is the reflection?
Yeah, so okay, so what you can do is, so you know this thing, and you also know that MY into MA equal to MB into MC, right, by power of point.
Yes. So wait,
So
but MP
like,
is equal to MC, right?
yes, so this is like MB square
Okay.
and MI MB, so you just cancel this.
Okay. Okay. That's it. Got it.
Okay, so uh now I just, so now what we were doing is we will like combine the first two configs. It was not necessary to draw a line, but okay.
What's the third property? I couldn't like.
Yeah, just a second. I'll go to that.
Okay.
Yeah, so the third one was this MHA
Yeah.
into MA is MB square equal to MC.
I just wanted to write it down.
Yeah. So can I scroll down?
Yeah.
Yeah. So you have this, then you have the median, and you have C median. So it's like fifth, I think, right? Whatever. So it says that reflection of HA about BC is S. And the next property is HA and K are orthogonal conjugates in triangle ABC. So like you can try to prove fifth, and sixth, like I think just follows.
K the Dumpty point?
Yes, K is done.
Yeah.
HA and which one are isogonal conjugates? You said?
HA and K. What is wrong with me? Okay, so these 2 points are orthogonal conjugates in triangle ABC. So anyone has any ideas? It's basically angle chasing again. So you need to use the fact that AHA and AS are orthogonal in A because this is the median and this is the median.
So is angle BAK equal to MAC? Who's asking?
Yes, these two angles are equal. That's true. Okay, so anyone got fifth one? I just start maybe follow complete. So what you can do is angle HABC is equal to angle HAAB by the tangency thing. So you have included this angle, so now you can equate this to this angle. Sorry, so you see. Does everyone follow this?
Yeah.
Yeah, so did everyone understand how we proved this thing, fifth one? So these two statements imply that HA and S are symmetric with respect to PC. So is the fifth statement clear?
Okay, since AS and AM are medians, we can say that angle HAAB is equal to angle SAC.
Yeah. So these are median and median, so they are isogonal. Okay, now I think like 6 shouldn't be too hard. It's again basically angle chasing. Also, you already have one pair of isogonal, like you know that this is median and symmedian. So showing that it's isogonal in B or isogonal in C would suffice. And anyway, they are like if you prove one, the other is always by symmetry.
I think I got that HA and K are isogonal conjugates.
Yeah, go on.
First, HA BC equals to HAAB.
Yeah.
and and KBA.
So you mean this is equal or okay? No. Okay,
And
I get what you're doing. So
KBA
this is
equals to uh, KAC.
yes, and these two are equal.
Yeah.
Nice. So we get that H and K are isopernal. Did everyone follow this? What you said? Guys, yes, no, probably
Yeah,
maybe.
I got it.
Nice. Okay, so this was the relation between Humpty and Dumpty. It's quite interesting. Oh, okay, so there is like one more relation. This is like quite nice because it's unexpected. Okay, so what can you say about the Humpty point? Sorry, D Humpty of triangle TMN. Okay, like maybe let's do this later. Let's first do another one. Or maybe like, we can complete them quite independent.
Could you define the Humpty point?
Sorry.
Could you define the Humpty point?
Okay, so Humpty point is defined here. So it's basically perpendicular from the orthocenter to the median, but this
Yeah,
definition is
sorry,
like
sorry. I forgot. Yeah, forgot.
yeah. So like this definition is not quite used, but basically these properties are mostly used. I mean, you can use this property or this property, something. And here K is the Dumpty point of triangle ABC.
I was actually familiar with the notation of that HM point, so I got confused.
Okay. So I think M was used there as midpoint. Sorry. Okay, so like K will always be used as Dumpty point. This is not standard notation. This is just notation I'm using in this. You can use your own notation. So like any wild guess what this should be?
Like K itself.
Yeah, that's true. So we want to show that this is same as K. Oh, wait, something happened. Can you see the screen?
Yes.
Nice. Okay, so do you have any information about these circles?
I think we can proceed using the isogonal conjugate formation.
Sorry, like your voice is not very clear. I got the isogonal conjugate.
DMK and DKN are both tangents to MN.
Yes. So
Oh,
these
right,
are
yeah,
like,
you're given it as a property, I think,
yeah. So these are tangents to MN,
which
and as you
means that
can,
it's just Humpty point from the
yeah,
other property.
yes. So this is the so K is the Humpty point. Did everyone follow? Sorry.
Yeah.
Yeah. Next. Okay. So the last thing we do with Humpty, this is like sort of like trivial, but still. So you have this median and your Humpty point. What can you comment about Humpty point of HA Humpty point of triangle BHSC?
Is it A?
Yes, that's true. Can you like outline the proof or if you have?
Because like AHAB is tangent to BC and AHAC is tangent to BC, and Humpty point can be defined as the intersection of the two circles, and the similar logic follows.
Yes, true. So that's basically it's symmetry about A and HA. So you get that it's the A. Okay, so let's move on to the next point. Okay, is everyone with me up to now? Is there any part I should get?
Can you repeat the last part, the last property ones?
Yes, so
How did you get it, the final?
yeah, so you know that HA is the Humpty point of ABC. So these circles are tangent to BC. It's like tangent here. Right?
Hmm.
And that's how you can also define the A in triangle BHAC. Like it's the circle through HA tangent to BC and circle through HA tangent to BC passing through C. So those two intersect again at A. So that's the Humpty point of BHAC.
Oh,
Thanks. Okay. So are there any other questions till now? Like anything related to what I did till now? Okay. So last question about Humpty. Where does the uh, Humpty point go under root BC?
What's the meaning of this? It would be meaning.
It's the root BC inversion
Oh,
followed by reflection about angle bisector. Reflection. Try to use this definition. It's like quite nice about the tangent circles. You can easily invert this thing. It will be better.
It goes to the point where it forms a parallelogram with ABC as the vertices.
No, I think that's where the Dumpty point went, right?
Oh yes, sorry.
This point should go on some point on the symmetrical. Which point?
So if AHAB is tangent to BC, doesn't it mean that it will become that circle will become a parallel line to BC?
Oh, but the line BC won't remain line BC anymore, right? Line BC will go to circle ABC.
Oh yes, so it'll become a line tangent to circle ABC.
Yes, that's true. So you will have this circle and so this is this.
Oh, so it just becomes like the meeting point of the two tangents.
Yes. So this is the HA dash. That was like I think we defined this to be T earlier or something. So it goes to the intersection of tangents at B and C. Did everyone follow why this is true?
The inversion is done with respect to A.
Yes, it's centered at A with radius root BC. So B and C swap there. And so HA was here. It will go to on the C median. It was on the median first, it will go to C median.
I just want to know, does the the midpoint of BC go to the like the point S, like the intersection of the median and the circle?
Yes, that's true. That's true. Because it will go on the C median and it will also on the circle. So it has to go to this.
Okay.
Thanks. So let's go with the next set of points. Okay, so this point is like just it just introduces the properties are quite easy to prove. It's not very involved. They are probably not looking perpendicular, but I understand. So you draw this circle with diameter AH, and so this point, second intersection, you define it as Q. This is like it's also is called Q point. Okay, so first property we have is that if M is the midpoint of BC, A star is the antipode of A, then you have these 4 points are correlated.
Okay, that's easy because A dash is just the A star is just the reflection of H about M.
Yes, true. And this
And
angle is 90.
yeah, it's a 90.
Yes, that's true. So first property was that Q. Okay, so second is BQH and CQH are tangent to tangent to BC. So this essentially is the statement that H is Humpty of basically Q Humpty of angle QBC. Try to use the first property, it like trivializes the proof. I mean, angle chasing works also. That's no problem.
Wrong. Because we essentially have that BAA star is equal to a 90 minus C.
The A star is equal to 90 minus what do you say?
Wait, I'll just check my mic. I don't know why my voice is very.
Okay. Okay, so angle chasing works. You can try to complete it. Then we will do. Another approach you can try is using power of point that we did above. Can you use power of point with respect to m and show that h is the q on t?
Is my voice clear now?
Sorry?
Is my voice clear now?
Yes, yes, yes.
So we know that A dash C B is 90 minus C, which implies
Let
that
me write. A star CB is equal to 90 minus what?
C, angle C, ACB,
Yeah, and 90 minus C.
which is just equal to A dash QB, and which is also equal to that B foot BC, and like EBC.
This angle,
Yeah.
yeah, and then HBC. Yeah, done. Nice. Okay, so this was the proof. Another proof was so MB into MC equal to MA star into MQ. It is same as MH into MQ because that's the reflection. Okay, I am not using like directed lens here. These are just absolute values. We'll probably have to add a negative if we are dealing with directed lens, but it doesn't matter right now. How to erase? This is equal to MH into MQ. So by definition, H is the quantity. Is it clear? Look at that. Oh, yeah. So I'm scrolling down. Okay, so this is like surprising now. Okay, so you know that HA also has on this circle, right? Because of the 90-degree thing. So we now claim that AQ, comma, EF, comma, PC, comma, HHA, HHA, and these all are concurrent. And the point of concurrency is called X equal to X point. So you need to show this.
Radical
This
axis,
follows
I
by
guess.
radical axis.
Yes, true. So you just consider a bunch of circles. So you can consider the diameter AH circle, diameter BC circle, then circle BC HHA, and probably something else. Or is this enough? And circle ABC. Yeah, so like just apply radical axis to these circles and you will get that. Another interesting thing to note is that this is D, then BC, comma, dx equal to -1. So D and x are the harmonic conjugates of each other. Does everyone see?
Yeah.
Nice. Okay. So this is a nice concurrency.
1 second. Could you
Yeah.
like how is it BC comma DX equal to -1?
Because this is like EF. So I'll just draw. So EF passes through X and BE, CF and AD are concurrent at H.
Okay.
That
Okay, I think I got it, yes.
yeah. Okay. So yeah. And what am I doing? Okay, so we have that Q have to say cyclic and Q E M B cyclic. I mean just group one after is proven by symmetry. This is just angle chasing.
Are the 4 points QBME? Actually, I can't see the concepts.
Are the points
QBME.
Q E M E? Yes, that's what you have to put. These are concept.
So like MQE
Where?
is
Okay.
MBE.
Q E. That's what you have to prove, right?
So angle MQE is
Yeah.
just angle HQE, that is angle HAE.
Yeah, and that is MB.
Right.
This also follows by power of point because we have HQ into HA dash is equal to HP into 2HE, which implies that HQ into HM is equal to HP.
Wait, I did not follow. Could you repeat?
We have HQ into HA dash is equal to HP into like 2 times of HE, and HA dash.
Yes. True.
Yeah.
Does everyone get this? Maybe just extend this and this is 2 times HE. So this is interesting. Yes. So does everyone see why these two coordinate vectors are cyclic?
Wait, how do you get it by power of point?
So so consider this thing 2 into HQ into HL is HQ into HA dash because A dash these two are equal.
Yes.
And that is equal to HB into 2HE because these two are equal.
Okay. So HQ into
that's it.
HM is equal to HP into HE. Oh.
Yes. Also, someone asked me what to have written beside Q. Yes, I written Q. This is like Q. Handwriting is certainly better. Also, like just as a thing, for those of you who know spiral similarity, Q is the spiral center. Basically, Q is Mickel point of quadrilateral BFEC. So Q is the spiral center taking FE2BC.
Why is Q the middle point? BFEC.
So you draw these diagonals, they intersect at H. You draw these diagonals, they intersect at A, and then you draw this. You draw circle AFE and I mean, okay, this doesn't matter. So you have this sort of configuration: A, F, E, B, C, and then you are drawing this circle and this circle, and they're intersecting at Q. So Q is the Mickel point.
Okay.
Interesting. Okay, so now these were all orthocenter type configs. We will now like deviate slightly and go with the last thing on our list today. That is the Sharkey table or spy point. All these words are like AOP slang. Just don't use them in context. Otherwise, you make it your points may get caught. So how do we define this? So this is an in-center config. So this is the point S. So that's how you define the Sharkey point, and like it is the Mickel point of again BFEC. Just like here the F and E are different, they are the touch points of in centers in circle, but that's the same thing. So obviously that follows is triangle SBF, similar to triangle SCE. Okay, so I guess we have done ratio lemma, right? Have you done ratio lemma?
Wait, how is it
Yeah.
defined again? Sharkey level point?
Okay, so you draw the incircle, you take these touch points. So you draw a circle through A, F, I, and E, and its intersection with circle ABC.
Oh, okay.
So it's a diameter AI circle. Okay, so if M is the midpoint of R, then then first property is that S dash T dash M. I mean these three are collinear. I mean I think we're like short of time, so I'll just skip the proof for now. It's trivial by ratio lemma. You calculate BS upon SC by this similarity, and then you use BM equal to BC and BD upon DC thing. So I'll just skip that for now if that's fine. Okay, so this is
We
one
just
one
have to
of the
compute the like the ratio, the f of function of s.
yes you have
F
to
of
just
S?
compute the ratio. True. So you can just I mean you can do that. It's no big deal. Okay, so now this is one of the important properties of Sharkey table, and like it's the last property we do today before we try to do some problem. Should do a better thing. Okay, so if you draw the perpendicular from D to EF, let's name this like P, then you have S, P, and I are collinear. Okay, I'll give you 5 minutes to prove this. Try this. Hint is you use
I remember
inversion.
proving this for a problem. I think I used inversion or
Sorry, your voice was cracked.
I remember proving this for a problem, I guess.
Oh wow, that's like quite cool. So you used inversion or you used something else?
I think I used inversion, but I'm not sure. I'll try both ways.
Yes, yes. So you can try inversion. It's like nice here. I'll give you a couple of minutes to try.
Wait, doesn't I just lie on AFE?
I lies on it lies. Sorry. I'm like quite bad at figures, as you can see. This is why. So try to see where the points go. A, comma, B, comma, C, and like circle ABC goes under inversion with respect to circle.
Goes to the 9-point circle of a DEF, I know that.
Yeah. So also you know that S will lie on the same circle, right? So as you correctly pointed out, ABC will go to 9-point circle of triangle DEF. Is everyone fine with this
But
or?
R can't be the midpoint because it is the image of A, so S must be the altitude.
Yes, true. So A, B, and C respectively go to the midpoints. So circle ABC must go to the 9-point circle, and S also lies on the same thing. So S lies on E. So S has to be the foot of altitude.
Foot of the altitude, huh?
Yeah.
So P and S just swap places in this inversion.
Yes. Also, wait. Why does S go to line EF? I mean, okay, you need to still need to show that S belong. I mean, the image of S will belong to EF.
Because AEF pass S lies on AEF, which passes through I. So
Yes,
circles go to
yes,
lines. Last
because
circles
A,
centers go to
E,
lines.
I. Yeah, so this circle will go to EF, and so S dash will belong to line EF. Yes, that's nice. So this was the property. Okay, what's the time? Okay, I think like we are short of time, but what's happening? But let's just do some problems because they are nice. And like you will get some idea on how to go about this. Okay, so yeah, P is the foot of perpendicular from D to E. Okay, so like I'll just give you a choice. Do you want to first do a also like it's not the end of configs, obviously there are many more configs, like there are mixed linear in circles, etc. Like probably Om can tell you better on that than me, still. So yeah. Yes. So like probably we can I think Om can share a handout if he has. I'll just ask him to. I'll give a choice. So do you want to first do a problem based on config geo and projective or config geo and inversion?
Config
Config
and
and
inversion.
inversion.
Inversion. Okay, thanks. I'll just see the problem. Yeah. Can you see the problem? Can you see the problem?
Yeah.
I'll just mention the source, or if you want to refer it, short list until the answer for. Oh, it's given here. Anyway. So I'll draw the diagram by that time you can draw it. Okay. I'll give this some time to try. Anyone has any ideas? Feel free to share.
Maybe root PC inversion can help because I guess B naught and C naught are well defined and means we
Yes.
know them, and then AX, that's just tangent to BC, which remains fixed. Means
Yes.
the circumcircle of ABC will go to BC, and so X will lie on BC. And we also have that B and C would be the midpoints of AB naught and AC naught. So I guess that might help.
Yes. Yes. You're on the right lines. Also, can you figure out where D goes under root BC?
Yes, I'm doing that right now.
Yes. Okay, so the root BC is the correct idea. I'll just draw a figure by that time being.
So D goes to A dash, or wait, let me just think of it again. A star.
Yes, it goes to the antipode of it. That's right.
Okay, by similarity, since A angle ABD is equal to 90. Yeah.
Yes. So I'll just denote the points with the dashes.
Wait, where does G go?
Where just
G, the center.
point is G will go to some point on the symmedian. We just need to care that it goes on symmedian. We don't really care where exactly it goes.
Okay, we just need the median. That's it.
Yeah.
But why don't we really care about G? Because it's essential in proving that it lies on the circle A dash, A, X dash, and D dash.
Yes, you only really require that these points are consecutive. P naught dash, G, B dash, A dash, and C naught dash, G dash, C dash, A dash. You can like uniquely define G using this and then later use some PowerPoint stuff.
Oh, okay, all right.
Also, I think it would be better if you draw this circumcircle. It is like more nice, as you will see. Also, can you figure out what D dash is to the circumcircle of A dash, B naught dash, C naught dash?
Circumcenter.
Yes, it's the circumcenter. Can you show it?
Yes, because angle AB dash D dash and AC dash D dash is 90, and C dash and B dash are the midpoints of AB naught dash and AC naught dash.
Yes. Well, so we know that D dash went to antipode of A. So D dash, C dash, comma, D dash, B dash are perpendicular to A dash, B naught dash, and A dash, C naught dash, and they are the perpendicular bisector. So D is circumcenter. So you also get that since these are the tangents and B naught, C naught, you get that these three are collinear, and this is 90, right? And you can like also join this maybe. So you have, I should probably increase the size. So yeah, this is 90 and this is 90. Does everyone follow till now, or should I repeat everything?
Why is D dash X B dash 90?
B dash X. Okay, so you got the part why D dash is the circumcenter of A, B naught, C naught.
Yeah.
And T is the, wait, what did I do? And T is the, what do you call it? T is the intersection of tangents, right?
Yes.
So, and this circle is like tangent to B dash, C dash.
Yes.
So, that's it. How do I explain this? Let me phrase. So, wait, how do I explain this? Just a sec. I directly drew that. Why is it 90?
Okay, so B dash C dash and B naught dash and C naught dash are parallel. And
Yes.
I guess it's then easy to show that D dash,
Right.
B naught dash, C naught dash, and T is like perpendicular. D dash T and B naught dash, C naught dash is perpendicular.
Yes.
Simpson's
So
line?
from there it follows.
Yeah,
No,
because
he's
D
asking
dash
why
is like-
TX is perpendicular to this thing.
Then it implies
Yeah,
that
because
X dash, D dash and T are collinear.
It implies,
No, like I think in that argument we would have we must have the D dash, X dash and T are collinear, because we know that D dash T is perpendicular to B naught C naught,
yeah.
and if we have the D, yeah, and B naught B dash
I
C
think
dash
they
is
should be
parallel to B naught
collinear.
C naught, and X
think-
dash, T dash and T are.
Yeah, I think there should be collinear. I'm not able to figure out why is it 90.
We have to prove that D dash X dash is perpendicular to B dash C dash or what?
Yeah, D dash X dash is perpendicular to B dash C dash.
So isn't this just 1 second, Simpson line?
It should
Because
be,
D dash B dash is perpendicular to AB dash, and D dash C dash is also perpendicular to AB dash. and A dash, B dash, C dash, and D dash are concyclic. So by
Wait,
Simpson
wait.
line,
Could you repeat what you said?
we know that A dash, B dash, C dash are concyclic with D dash.
Yes.
And then since D dash, B dash, and D dash, C dash are, 90 degrees. So
Yeah.
by Simpson line, X dash should also be collinear with those two. And X dash is, so we are done.
Oh no, but X dash we are referring to be the circle passing through B naught dash, C naught dash, which is tangent to B dash, C dash.
Okay, so sorry, I think I made a mistake in the definitions.
Do we have a method to show that the circumcenter of B naught dash, X dash, C naught dash lies on D dash T? Then we'll be done, I guess.
B naught dash?
Considering the circumcenter of B naught dash, X dash, and C naught dash. I think that might,
Yeah, probably angle chasing. Let's just check. Ah, okay. It's indeed angle chasing. No, wait. Did I? What did I do?
G dash is the Dumpty point of A dash, B naught dash, C naught dash. Because we
Yes,
know
it
that.
is.
Oh, yes.
Yeah. Okay. So, okay, it is like easy. So, to prove that d dash x dash is perpendicular, so you consider angle b naught dash x dash c dash. So this angle by parallel lines it's equal to this angle, and by tangency it is equal to uh, it's by tangency it's equal to this angle. So you get that x dash b naught dash equal to x dash c naught dash, and so it lies on perpendicular bisector. So d dash x dash is perpendicular to b naught dash c naught dash, which is parallel to b dash c dash.
why was the X dash B naught dash C naught dash equal to X dash C naught dash B naught dash?
X dash B naught dash. Because you look at this angle, the angle
Oh,
B
yeah,
naught X dash C dash.
Okay. Yeah, got it.
Yeah. So does this make sense to everyone? Should I repeat this or is it fine?
Oh yeah, we got it.
Fine, yes.
Nice. Okay, so now I'll just give you a hint. So what now you have to prove. So essentially the statement has now been reformulated. So we want to show that A G D X. Okay, I just drop the dashes now. It's pretty obvious what you have to do now. So AGDX should be concyclic, right? Because DGX were collinear there, so we have to prove that AGDX is concyclic here. So an obvious choice of power of point is T, right? So try to compute powers with respect to T. And you need to like introduce one more point, and after that it's pretty obvious.
Wait, so how is G the Dumpty point of ABO dash and CO dash?
Okay, so it is like B here, this is B naught. This is these are the midpoints, right? B dash and C dash. And
Yeah.
you have this.
Yes.
So that was one of the results we proved for the Dumpty point. That
Oh, okay.
A midpoint vertex and Dumpty point were concentric. I mean, okay, it doesn't really matter here, but it's fine. It's nice to know. So you need to now like calculate powers with respect to T. Like introduce some other point, and then it's like nice.
Would we calculate powers with respect to t?
Yes. Okay, so the construction is like, I just like say the construction. So you extend these two to meet at some point y. Now try to compute powers with it. Like try to chase with respect to y.
Had a doubt, if d dash g dash a is 90 and d dash x c dash is also 90, then won't we have those four, that one small point at that d dash x dash g dash concyclic?
Wait, could you repeat? You
We
have
have that d dash x dash c dash is 90 and d dash g dash a is a is 90.
why is g dash a 90?
D dash G dash A is 90 because like you said G was
Sir,
the
yeah, empty
empty
point.
point. Yeah, but then how can A lie on that circle?
How can a lie on which circle?
You asked us to prove that A lies on X dash D dash G dash, right?
Dash g dash, yes, but you showed that a c dash g dash d. Wait, what did you show exactly? So this angle is 90. This angle is 90. So what do you get? So what do you get? Okay, wait, says I'm doing something wrong. Probably.
I don't think that G dash would be the dumpty point. I made a
Yes,
mistake.
I am
I'm
also
sorry.
doubting that, right?
Yeah. I messed up the property. Sorry. I mean, I messed up thinking right now. G is not the midpoint. G is not a dumpty. Sorry. That's not the property of dumpty.
Okay.
It's not. It's not. Sorry.
Yeah.
Sorry. My bad. I was like thinking something else. This is like not 90. Okay, so I'll give you a hint because we're already very much over time. So can you show that y lies on this circle? Select the second one.
Yes, by angle chasing, because c dash y co dash and is equal to a, because it is perpendicular, like t y and the symmetrical point makes a isosceles triangle, so that's a, and then c dash a dash co dash is also a.
Yeah, okay, yes. So, oh, sorry, I mean this one. Yeah, so you get as y lies on this circle. I mean, you can angle change in many ways. But is not very linear. And so now it's quite easy to finish. So you get that Tg into Ta is equal to Tc naught into Ty is equal to Td into Tx, and so Ga dx are cyclic. Do you get this?
Wait, so
Do
how
you,
is to into tx? Oh, 90. Okay, so that's again.
yes. Okay, so that we are already over time, so let's now do the projective question. I'll just mention this. If you're interested to try, you can. Wait, I'll just check the suggestions and we'll start the chat. Okay, so it's TSTSP 2020. Okay. Yeah, it's TSTST 2020/2022. You can this involves config and projective, so you can try this. It's quite nice. This involves the inversion, the in circle config type. So I hope you enjoyed the class. Anyone has any questions?
Could you please send the notes of this class?
Okay, yes, sure. I
Thank
mean, my handwriting is like quite terrible, but okay, I'll
you.
share notions.
Yeah, thank you.
Yeah, I guess we can stop the recordings.
Hmm.
Yes.